All right, so first of all, feel free to ask questions. As I mentioned, we will have TAs in addition to Cathy who will be leading this. You'll notice their names have a TA next to it, so feel free if there's any questions that you have during the time, throw them into chat, and our TAs will be working on answering that. So there will also be hands-on exercises during this. So Cathy will lead through a demonstration of how to perform a specific function and work with electronic health records. And then we'll actually have breakout rooms where you will be able to kind of go through with an individual TA and do that activity on your own, in addition to kind of some questions that we have set up for you all to do. So really get some hands-on experience in order to jump into the researcher workbench, work with electronic health record data. So we're really excited about that. As a reminder, you will be needing to use the researcher workbench during this activity. So you will need to be a registered user to kind of engage in this workshop. And you also have to have that access active as well. An overview of what we're going to be doing. So we have our initial welcome and overview of the research program, just to make sure that everybody is kind of on the same foot. So we're overviewing what All of Us is and the researcher workbench. And then that exercise 0, which hopefully everybody or almost everybody had completed in advance, duplicating a workspace. So we do have a specific workspace that we have shared with you all that we're going to be working off of today. So just making sure that if anybody didn't duplicate in advance, we do have that duplicated as early as possible. While we go into the next sections, which Cathy will be overviewing electronic health record data and introduction to OMOP. Then we'll kind of really be jumping in on the second half of the hands-on exercises in the workbench. So using that cohort dataset builder, building cohorts, using SQL, and harnessing longitudinal electronic health record data. After that, we'll have kind of a wrap up, leave a survey for you guys to fill out to give us feedback. We'd love to get feedback as much as possible to make these workshops even better in the future. One last final reminder, this is for registered users only. You will need registered tier access and active access. So we will, if you don't have that, if you join somehow and you don't have that, we will be posting a video of this recording within a week on our user support hub. So if you miss anything or if you want to share this with other users, we will have a recording for you to use. And then last thing for the intro, we want to get to know a little bit about you. Who are we talking to? So we have a poll set up. So if you could just quickly answer the poll, this will be very helpful for us to kind of know who's joining this workshop, who's interested, and how can we better tailor this to make sure that we are engaging with you all as best as possible. Thank you all for these quick responses. It looks like a lot are A or B, so that's good. At least for our anticipated audience, we're hitting that. And it seems about split pretty evenly between those two. So that's great. Yeah, we'll definitely have for all of those new people, it will be definitely, hopefully you'll be able to follow along. If you have experience, hopefully you'll be learning something new and really knowing how to engage with that data on this platform specifically. So thank you all so much for filling that out. It's great to see that we have a split of experienced and new people. And with that, I believe I will be handing it off to Cathy. So I'm going to stop sharing, Cathy, so you can take over and do your thing.
Awesome. Sounds good. Thank you so much, Michael, for that very kind introduction. All right. Can everyone see the slides okay?
You're good to go.
Awesome. So hi, everyone. My name is Cathy Shyr. I'm a postdoc at the Data and Research Center. It's really great to see everyone, and it's awesome to see that perfect 50-50 split from the poll today. So for the next few hours, I will be taking you through a set of material to introduce and familiarize you with working with the All of Us electronic health records data. And hopefully by the end of this session, the goal is for the teaching team to help you gain a working knowledge of how to maximize the utility of this great data resource and understand how to leverage it for your own research interests. So before diving into electronic health records, I would like to give everyone a 30,000-foot overview of the All of Us research program. So the goal of the All of Us research program is to accelerate health research and medical breakthroughs to enable personalized prevention, treatment, and care for the diverse populations in the United States and beyond. So there are three core pillars to our mission. The first pillar is to build and nurture enduring partnerships with at least 1 million participants who reflect the diversity of the US. The second pillar is to build and deliver one of the largest and richest biomedical data sets and make that broadly accessible to researchers and users like you. And last but not least, the last pillar is to catalyze an ecosystem of communities, participants, researchers, and funders who will make all of us an indispensable part of health research for years to come. So diversity is truly at the core of the All of Us research program. And we're really happy to share that we currently have over 413,000 participants who have completed the initial steps to register and have agreed to share their data with the program. Among these, 75% are from communities underrepresented in biomedical research, and 45% are from racial and ethnic minority groups, making the All of Us dataset the most diverse of its kind. So on this slide, I have a summary of the data that are currently available, and there are two main types of data, phenotypic data and genomic data. So within the phenotypic data, we have survey responses, physical measurements, electronic health records, as well as Fitbit records. Now, for the genomics data, our last release featured nearly 250,000 whole genome sequences, as well as genotyping arrays, structural variants, and long-read sequences. So today we'll only be focusing on electronic health records, but I do want to point out that the All of Us User and Research Support Hub provides a myriad and a wealth of helpful resources, including tutorial notebooks, articles, and workshops just like this that will introduce you to the different types of data that we currently have available. So after today's workshop, you're interested in checking out some of these other resources, I highly encourage you to do so. All right. So at the Data Research Center, we really prioritize maintaining a balance between keeping the data safe and making it useful to researchers. And so there are two core values here. The first is that we really want to make this data set broadly accessible to a wide audience. So we're thinking about how we can make the data useful by removing unnecessary access barriers and technological barriers. At the same time, we also want to honor our commitment to protecting participant privacy. And because privacy is really at the core of what we do here at the Data Research Center. And so we really try to strive and build a system that the participants can trust and continue to be willing to share their data with the program. And one of the ways that we keep the data secure is in the way that we share the data with users. So traditionally, the approach is to have a centralized copy of the data, and then the users can then share or copy that data set into their own local environments or local machines. And so with this, there may be a higher risk of compromising data security, and the data may be less accessible. So as a result, at All of Us, we have this approach where we have a centralized platform of a centralized copy of the data set, as well as a set of tools so that we can bring the researchers to the data. So with this approach, there are a couple of advantages, including lower computational cost, the data is more secure and more accessible as well. And this centralized platform is called the All of Us Researcher Workbench. So the Researcher Workbench is a cloud-based platform with a suite of tools to help support data analysis and collaboration. And there are four main components to the Researcher Workbench. The first component is workspaces. So you can think of this as essentially a file cabinet that you can access and store specific data files for a particular project. You can also share this workspace or file cabinet with your collaborators. And then in each workspace, we have notebooks, which are high-powered notebooks that can help perform queries and analyses. So currently on the researcher workbench, we provide Python, RStudio, and SAS. The last two components at the bottom of the slide are the Cohort Builder and the Dataset Builder. And these are custom point-and-click tools that are very easy to use and that you can leverage to create cohorts and data sets for analysis. So in today's workshop, we're going to get some hands-on experience with all four of these components. So with that being said, I know that all of you should have gotten an email about a week ago about duplicating a workspace ahead of time. So maybe just give me a thumbs up or a virtual thumbs up if you were able to successfully duplicate this workspace, just so that we have a sense. Awesome. We have a lot of folks who were able to duplicate it. And no worries if you haven't. I will be walking through the steps on how to duplicate the workspace, and we'll also set aside some time for everyone to go through the process. All right. So if everyone could open up a web browser, Google Chrome is recommended, and go ahead and navigate to workbench.allofusresearch.org/login. I'll also put this in, or if one of the TAs could put that in the chat for me, so that everyone can navigate to the same page. Okay, I think I've got it right here. All right, so awesome, thank you, Sam. So go ahead and click on sign in. All right, so I'll give everyone just a few seconds to sign in. And once you log in, you'll see a landing page that looks something like this, as long as you have an active Researcher Workbench account. So what you want to do is look for a workspace titled Workshop Attendees, Intro to All of Us Electronic Health Records Data. And if you don't see this workspace, please let one of the TAs know, and we can add you to this workspace. So if you don't see this workspace tile, you can try clicking on See All Workspaces. And I've got a lot here, but you want to find the one that says Workshop Attendees, Intro to All of Us EHR Data. And then the next thing that you want to do is click on the three vertical dots and select Duplicate. So if at any point you want me to slow down, please feel free to just unmute and just let me know. All right, so once you get to the duplication page, you want to enter a specific workspace name. So I'm just going to say duplicate, and you want to assign it a unique name. So typically what I like to do is just keep the workspace name, but then add my initials to the end. And so here you want to select register tier, dataset version 7. So once you get down here, you're going to see a little option, a little check mark for sharing the workspace with the same set of collaborators. So you want to make sure that you don't check this one. So leave this box unchecked, because checking this box will actually share the same workspace with everyone who are registered for the workshop. So go ahead and leave that unchecked. And then here you can select your current billing account. All right, so then you will be prompted to answer a number of questions, but because this is a pre-existing workspace, you can just go ahead and skip all the way down to step 6, request for a review of research purpose description, and then go ahead and select no. So go ahead and just ignore all the questions and skip down to the bottom of the page to question 6. Once you select a no, you can click Duplicate Workspace. Go ahead and click Confirm, and then it will just take a few seconds to a minute to spin up. All right, and so once you've done that, we'll actually move into the breakout rooms now, but for the TAs, make sure to also ask the attendees to spin up a general cloud environment. So with that, I think, Michael, we're ready to jump into our breakout room. So right now we'll actually take you guys to a breakout room to work on this exercise, make sure we have this workspace duplicated and ready to go for the rest of the workshop. So any questions so far about duplicating a workspace? Awesome, sounds like we're good to go. So Michael or Ashley, if you could assign everyone to a breakout room for 10 minutes.
So you all be able to see, we have multiple breakout rooms with different TAs associated with them. So everyone feel free to join a breakout room at the bottom there. Please try to kind of spread out into the different breakout rooms. All of our TAs are wonderful. So please feel free to jump in there and you'll be able to kind of work through with your TAs. Thanks, everyone.
All right. Awesome. Welcome back, everyone. It's nice to see a few of you with your cameras on. All right. So hopefully everyone was able to duplicate their notebook, duplicate the workspace, and also spin up an computing environment. And don't worry if it's still spinning up, we're just going to leave that in the background as we go over the rest of the lecture. All right. So now let's talk about give you guys an overview of electronic health records in All of Us. So electronic health record, EHR, is a digital version of a patient's paper chart. And generally, EHRs can contain information about a patient's demographics, diagnoses, medications or drugs, procedures, visits, tests, devices, images, or clinical notes. And this data can be broadly divided into two categories. Structured data, so think of information that we can store in a table format, like an Excel spreadsheet. On the other hand, images and clinical notes are considered unstructured data. So this type of data, we cannot directly store that information in a table format. So collecting electronic health records in the All of Us research program begins with the consent process. So on the left-hand side of the screen, I've got a screenshot of the sample EHR consent form. And so essentially the takeaway is that this form is asking participants for their consent to let the All of Us research program ask their healthcare providers to share their EHR with the program. And one thing I want to point out is that All of Us is not the same as medical care. And so as a result, the program is not subject to HIPAA or US laws for protecting sensitive health information. But with that being said, the data that are shared with All of Us, not just electronic health records data, but all data, are protected by very rigorous privacy rules, which I'll talk about in just a little bit. So in general, All of Us removes names and other identifying information from the participants' data to protect their privacy. And the program follows all US federal, state, and local laws and regulations for keeping participants' information safe. Now, on the researchers' end, they also must undergo a very rigorous training, like all of you have, and agree to a number of rules. So this includes promising that they will not try to find out who the participants are, meaning that they will not try to re-identify participants using the data set. So to maintain participants' data privacy, the All of Us research program uses a tiered access model, and there are three main tiers. The first tier is the public tier, which I like to call the unlocked tier. So essentially, data from this tier can be accessed by anyone with an internet connection, and they don't have to log in. Within this tier, we only provide summary statistics and aggregate counts. Now, the next two tiers, the registered tier and the control tier, live on our Google Cloud platform, and these two are the locked tiers. So the registered tier is available to anyone within a trusted organization who proves their identity and enters into a data usage agreement with the program. Within this tier, the data is less granular, and so as a result, there's a lower risk of re-identification. And within the registered tier, users will have access to EHR data, surveys, physical measurements, and wearables data. The last tier is the control tier, and this is available only to trusted investigators who have a valid login.gov account. And within this tier, the data are more granular, so it's more detailed, but with that, the trade-off is that there's a higher risk of re-identification. Within control tier, in addition to the data from registered tier, users will have access to genomics data, additional fields from EHR and survey data, as well as unshifted dates. So to give everyone a better idea of what exactly that means, so here's a table with a number of different demographic fields across the registered tier and the control tier. Now, there are three major takeaways. The first takeaway is that the control tier provides unchanged information. So if we look at the different fields, for example, date of birth, date of events, in the registered tier, we do randomly shift those dates by 1 year while maintaining the temporality in the data. However, in the control tier, we do not make any changes. The second takeaway is that the control tier contains additional data. So you can see here for information on death, causes, active military duty status, we do suppress that information within the registered tier, but not in the control tier. And last but not least, the third takeaway is that control tier provides more fine-grained information. So for example, for some surveys, asking participants about their race, ethnicity, sex, or gender, we do generalize some of their responses in the registered tier. So the data is not as granular. However, we don't make any changes to that within the control tier. So one very helpful resource that I would recommend everyone to look into is the All of Us Data Dictionary. And with this, you can understand how some fields are defined and whether or not they've been either amended or suppressed for privacy reasons. So are there any questions about the overview of electronic health records in All of Us and the different data access tiers? Hearing none?
I
Okay.
think I have one question, like, so how one can become like a control tier? So like,
Yeah, exactly. That's a great question. So first, you have to make sure that your institution has control tier access with the program. And so if you do, then you will have the option once you completed your training for the registered tier, there will be additional options to complete a second set of training and also a data usage agreement in addition to the registered tier in order to access the control tier.
thank you.
Awesome, thanks. All right, so let's go ahead and talk about how the EHR data on All of Us are stored and structured. So with this, we can't talk about data structure and standardization without talking about OMOP. So OMOP, or Observational Medical Outcomes Partnership, is an open community data standard that is maintained by a group called Odyssey. And so really the two fundamental things I want everyone to take away from this is that there are two main components to OMOP. First is that it stores the All of Us data in a relational database. And the second is that it standardizes all the medical and EHR concepts. So the first is data storage, and the second is data standardization. So let's start with the first component, the data storage. So here is a schema of the OMOP relational database, and there's a lot going on here. So we're going to break it down bit by bit. So here in this schema, the color rectangles represent different categories of EHR data. So for example, in this blue color rectangle, we have clinical data. And so within this rectangle that contains information about the patient, so we have information about their person, their visit occurrence, their conditions or diagnoses, what drugs or medications that they've been exposed to. And then in the red, we have information about their healthcare system, for example, the location, the site at which they received care, and also information about their provider. Now, within each color rectangle, we have a lot of smaller rectangles that represent data tables. So essentially, we can just think of them as an Excel spreadsheet. So take, for example, the condition occurrence table and the measurement table. So again, we can just think of them as spreadsheets where the columns represent different fields in each of the tables. So going back to the schema, we see a lot of arrows that are going across and connecting different data tables. So if an arrow connects two rectangles, then that means there's a key variable that is present in both tables that allows us to merge two tables. So going back to our example with the condition occurrence table and the measurement table, can someone tell me what is the key variable here that allows us to join these two tables? Person ID, awesome. Yeah, exactly. So this here is a key that links the two tables, and it's very important so that we can combine or join tables together. And we'll get some practice with this in just a little bit. All right, so one of the very helpful resources when it comes to navigating different OMOP tables and column definitions is the Odyssey website. So I would like everyone to go ahead and open up a browser and then navigate to this link here. I'll also put in the chat for everybody. I'm going to go ahead and navigate to this. I'll also do the same. All right. So this is a page that summarizes the list of different data tables and the fields within each table in OMOP. So on the left-hand side, we're going to see a list of the data tables that we just saw from the slide. So we have information about a person, right? So here's a table description. This table serves essentially as a central identity management for all persons or patients who have encountered who have an entry in their electronic health records, and it contains information that uniquely identifies each patient or person. So if we scroll down, we can see the different columns or the fields in this table. So we have person ID, which is a unique identifier for each participant in the All of Us research program. We have information about their gender, year of birth, et cetera, et cetera. Okay, so we're going to flip back to the slides. And we're going to jump into our first exercise, which is working with OMOP tables. And to help us do that, we're going to follow John. This is not a real participant, on his patient journey. So John was diagnosed with type 2 diabetes on July 1st, 2018. At that visit, he had his A1C measured. And shortly after his diagnosis, his doctor prescribed metformin. Then 3 months later, he came back for his routine checkup, had his A1C measure, and then also got his metformin refilled. All right. So here's the question that I would like everyone to try to answer. So which OMOP tables would you look at to find information on following components of John's journey? So which OMOP tables would you look at to find information about metformin, about type 2 diabetes, and A1C measurement? So go ahead and use that link that I share in the chat, and then look through the list of OMOP tables. And once you have an answer, go ahead and just unmute or type in the chat. Awesome, thank you, Yvonne. So just wait a couple of seconds for everyone to take a look at the different tables. And once you have an answer, please feel free to type in the chat. Awesome. Looks like everyone's getting the hang of it. Yes, perfect. So let's just walk through it together. So on the left-hand side, we've got a list of different tables. And the first thing we want to look at is, let's say, metformin. And so that information about any type of exposure to drug or medication will be stored in the OMOP table called drug exposure. And so we can scroll down here and see what type of information we have access to. For example, person ID, the drug concept ID that uniquely identifies each medication, drug exposure start date, start time, end date, et cetera, et cetera. Now, with type 2 diabetes, that would fall into the condition occurrence table. So this table will contain information about the presence of a disease or medical condition stated as a diagnosis, a sign, or a symptom. And last but not least, for A1C measurement, that information will be stored in John's measurement table. And so this table contains structure values, numerical, categorical, that are obtained through systematic or standardized examination or lab testing of someone's sample. Okay, so let's go back to the slides. And so on the left hand of this flow chart, I've labeled essentially where each of these concepts would live. So are there any questions about, go ahead, Yvonne.
Just a quick question. With the drug exposure, does it matter if it's the generic name or the trade name?
Yeah, that's a great question. So when we are looking for concepts, there is definitely a distinction between the generic name versus the trade name. And it's really up to the user or the researcher to essentially select which one you want to include for your analysis. And so we'll actually get into that in just a little bit. We'll see the different types of data that we have available. So, awesome. Any other questions about this exercise, about navigating different OMOP tables? And thinking about how different pieces of a patient or participant's journey map to different tables.
So I have a question about the type 2 DM. Is it possible to identify from the observation table?
Yes, it's also possible. And so this, and then again, I think that also kind of goes in hand with Yvonne's question as well, is that when you're working with EHR data, you have to think very carefully about how these variables are defined and where they are, essentially the data provenance. So in this case, we're thinking about type 2 diabetes as a diagnosis. So we're thinking about it from the condition occurrence table, but you're also right that it could be an observation and as a result, documented in the observations table. And so you, once you're working with the data, you do have an option to select where these concepts are sourced from. Does that help answer your question?
Yeah, thank you.
Awesome. Okay, perfect. So let's move on. So that was a little bit about data structure. Now let's talk about how OMOP standardizes the medical concepts in All of Us. So there are 6 major OMOP EHR domains: drugs, conditions, procedures, devices, observations, and measurements. Now, OMOP standardizes the vocabulary or the terminology within each domain. And so what that means is, let's just take, for example, if we just look at the conditions domain, the standard vocabulary in the conditions domain is SNOMED. So what that means is that OMOP will take these source vocabulary. So for example, ICD-9, ICD-10 billing codes, or let's say mesh headings. So we'll take these source vocabularies and then map them or standardize them to SNOMED. And the reason for this is, if we think back to John's patient journey, let's say, he sought care at, let's say, academic medical institution, and at that healthcare provider, they use, let's say, ICD-10 billing codes. But For example, if he had gone to a community health clinic, then that healthcare provider might be using, let's say, ICD-9 billing codes. And so even though, we have two codes that are indicating the same thing, the idea of OMOP standardization is that we want to harmonize it and standardize different vocabularies so that we're all on the same page here. So let's get a little bit of practice with this. So I want to introduce a helpful resource called Athena, which is a dictionary of all of the OMOP standard vocabularies. So go ahead and open up a browser and navigate to this page here. I'll put this in the chat as well. So if we navigate to Athena, we're going to see this landing page where we essentially have a search bar for different concepts. So if we go and search, let's say a random concept, let's say AFib, atrial fibrillation, you can click search. And this is going to bring a page of the different concepts that we have in OMOP. So the first column here represents the concept ID, which is a unique identifier for each concept in the All of Us research database. The second column is the concept code. So here is the name of the concept. You can see this is disorder. This is a standard concept because its vocabulary is SNOMED. And this lives in the conditions domain. So in contrast, if we look at the second entry, it's also atrial fibrillation, the exact same concept. If we ignore the capitalization, we see that this is a non-standard concept within the conditions domain because its vocabulary is mesh. So essentially, in EHR data, you're going to have a lot of different concepts that essentially mean the same thing. But the idea of OMOP is that it's able to standardize these different source vocabularies to a standard vocabulary. In the case of the conditions domain, that standard vocabulary is SNOMED. All right, so let's get some practice with this. So are there any questions about the content that we just talked about standardization and using OMOP and using Athena? Okay, so let's jump into exercise 2. So in exercise 2.1, I would like everyone to use Athena and find the standard concept ID and the standard concept code of type 2 diabetes. Okay, awesome. So we see some responses trickling in. Yes, I think everyone's got the hang of it. All right, so let's go ahead and go over this together. So let's go ahead and search type 2 diabetes in Athena. And we're going to see a list of search results. Again, since this question is asking for the standard concept and standard concept ID and concept code, that actually corresponds to the very first search result here. So the standard concept ID is 201826, and the standard concept code is this guy right here, right? And we can see that this is from the conditions domain, and it is the standard concept because the vocabulary is SNOMED. So, yeah.
And I put it in the chat because I know that you can search with the ICD-9 or ICD-10 codes. Does SNOMED harmonize them? And then looking at this table, not.
Yes, you read my mind. That's actually what we're going to talk about next with this exercise, just about 2 slides away. So I'll get to it in just a little bit. Okay. All right, so are there any questions about exercise 2.1, looking up the standard concept ID and standard concept code in Athena? Okay, Awesome. So I do want to just quickly give everyone an overview of the difference between concept ID and concept code in OMOP and All of Us. So here I've got a list of different concepts. They can range from psychiatric treatment, serum, to drug ingredients like antipyrine. So what you'll notice here is that all of these different concepts correspond to the same exact concept code. So if you have a collaborator who comes to you and says, hey, I'm looking at the concept code 1001, you're not really going to know which of these concepts they're referring to unless they give you more information about, let's say, their vocabulary or concept class. But in OMOP, the concept ID is really important because they uniquely identify a concept in the All of Us research database. And so as a result, we typically like to use the standard concept ID whenever you're looking up concepts or medical terms. Okay, so with that being said, let's talk about kind of going back to Yvonne's question, looking at the difference between the source vocabularies and how they get standardized to the standard vocabulary. So let's go ahead and take a look at John's patient journey again. So on October 15th, he reported having chest pain. And then in January of 2019, he continues to have his routine checkups. And then at that visit, he had an atrial fibrillation. So for exercise 2.2, I want everyone to try using Athena to find the concept ID and the standard concept ID for the ICD-9 code 427.31. So this is going to be a little bit more nuanced than the first exercise. Now, instead of working with the standard vocabulary, we're going to be working with the source vocabulary. So go ahead and try it out. And then once you have an answer, go ahead and put it into the chat. All right, I see a couple answers in the chat. So you guys got the concept ID correct.
I found some web results. I'll send them to your iPhone.
Okay, I think Siri wants to participate as well. So
Here's what I found.
oops, sorry about that. So we do, you guys got the correct concept ID, but not the correct. Yeah, Catherine, you've got it. All right, so let's go over this together. So let's go ahead and search up. So in Athena, you can actually directly search up a concept using its, let's say, ICD-9 billing code. So I'm going to search a 427.31. Did I get that number right? Okay, there we go. So here you can see that the concept that's associated with this concept code is atrial fibrillation. And we see that this is a non-standard concept in the conditions domain, and its vocabulary is the ICD-9. So the concept ID associated with AFib is 44821,957. But in the second question, I was asking everyone to find the standard concept ID, right? So remember, if we, go back to the slides and we think about here, we have a source vocabulary and that gets mapped to a standard vocabulary, right? So the standard concept ID is the concept ID that is associated with AFib in the SNOMED vocabulary. So, and the way we can find that is if you click on AFib, you can look at the concept relationship table to the right, and you can see there's a mapping from the non-standard vocabulary to the standard map in OMOP, and this gets mapped to the standard concept in SNOMED. So the standard concept ID is 313217. So the answer to this question is that the concept ID is 44821,957, and the standard concept ID is 313217. So Athena is a great way for researchers to essentially make the connection between non-standard to a standard mapping. So are there any questions about exercise 2.2? Perfect. All right, so now we're going to, yeah,
Sorry,
go ahead.
I have a question. Yeah. So let's say if one wants to search on like get a lot of EHR that related to this one. So we
Yeah.
need to look for the standard concept ID.
Yes, yes.
not
I
the
would
concept ID.
personally,
Yeah.
I would personally recommend looking up the standard concept ID to perform your cohort queries on the researcher workbench. There is also an option to also use, let's say, the source concept ID. So in this case, the source concept ID would be 448-21957. You can also look up conditions using this concept ID, or you can also use the original source code, for example, the ICD-9 code as well. So you do have a couple of options, but in All of Us, all the data are harmonized and standardized in a way so that essentially essentially the same concept, but with different codes are all mapped to the same standardized concept ID. So if you just look up this one, you will be kind of catching everyone who has AFib in the data set. But if you use, let's say, this ICD-9 code 427.31, you might be just capturing participants, like John, who went to a specific healthcare provider and who uses ICD-9 billing codes to denote a diagnosis or a billing event. Does that help answer your question?
Yeah. So roughly speaking, let's say if like the total number of people of interest will be 1,000, if
Yeah.
we go with the ICD-9 code, we might capture just a fraction of that.
Exactly.
If we go with standard concept ID, we capture every person that was inputted from the different sources.
Exactly.
So it's way more inclusive
Right, exactly.
to use standard concept ID.
Perfect. You put it perfectly. Yeah. So it really just gets everything on the same page and standardizes and harmonizes the data. Okay.
Thank you so much.
Awesome. All right, so let's go ahead and move on to working with the researcher workbench and trying to build a cohort. So we're going to go ahead and dive into two different approaches for building a cohort. The first approach is to use the cohort and dataset builder, which are the point and click tools that I've talked about at the beginning of this talk. These are very free and easy to use, customized tools, free in the sense that it does not require the user to spin up a cloud computing environment. So let's go ahead and navigate to the cohort builder. So go ahead and go back to your researcher workbench and navigate to the data tab. So it's the first of the three tabs here. And so for now, I would recommend just watching the demonstration. We'll have a breakout room in just a little bit so that you guys can try it out. So first you want to click on the plus sign here to build a cohort. And so then you will be prompted to add a number of inclusion/exclusion criteria to define your cohort. So the first thing we're going to do is we're going to build a cohort of participants who look like John, right? So remember, John has type 2 diabetes. So we're going to search diabetes here. And in this exercise, we're just looking at the conditions domain. And like Bronco said earlier today, that we can also look for it in the observations domain as well. So it really depends on kind of your research question and how essentially where you want the data source to be. So for this exercise, we're going to just look at conditions domain. We're going to pull up. So this is going to give you a list of the different terms here. So here we want specifically type 2 diabetes. And we're going to click this plus sign. And it's going to add this criteria to our cohort. Then you want to go to the bottom right and select finish and review. And here you can see we've got type 2 diabetes here. And then you can also additionally and optionally add a number of modifiers. So for example, if you just want to look at people who had type 2 diabetes, let's say greater or at the age of 50, you can specify that. You can specify the number of occurrences that they have. So the number of type 2 diabetes entry someone has in their specific EHR. So you can specify that as, let's say 3 or more. You can also specify the different visit type as well. So there's a lot of granularity here. So I'm going to go back and just not select anything for now. I just want anyone who has type 2 diabetes in their EHR, and then select apply modifiers. Then select save. And so once we click save, you're going to see that the total number of participants in my cohort so far is about 52,000. And on the right here, you can see a very nice breakdown, a visualization of either the demographics or a race and ethnicity breakdown in the cohort. All right, so let's keep going and add a second criterion. So remember that John was also taking metformin. So let's go ahead and search metformin. And we know that this is in the drug domain. So now here, this gets to your question, Vaughn, earlier about looking at the brand name versus the trade name. And so in the Cohort Builder, you can see the different types of metformin that we have. And so depending on, again, your research questions of interest, you can select a very specific one. In this case, for this exercise, just for the sake of illustration, I'll just select metformin here. So anyone with any type of metformin, I don't really care which brand name they had, just anyone with metformin in their EHR. So again, you can also apply different modifiers here. I'm just going to leave them untouched and then go ahead and save this criterion. And once we save that second criterion, you're going to see that the total number of participants in my cohort decreased to 27,000. So let's keep going and add a third one. John also had his A1C measure, so we're going to go to the labs and measurements table. And again, you have a lot of essentially flexibility in terms of which specific term you want to look at. In this case, I'm going to look at the first one, so hemoglobin A1C in the blood. If you click on this slider, again, it's going to open up the modifiers. So you can select participants who have any value of A1C in their EHR, or if you want to stratify by, let's say, I want to look at the diabetic range. So anyone who has an A1C greater than or equal to 7, you can specify that as well. So I'm just going to go ahead and just any value exists, add and save the criteria. And then once again, as we continue to essentially define our cohort, the number of participants decreases because we're adding essentially these criteria. The relationship between these three criteria is and, right? So they have to have type 2 diabetes and metformin and A1C value. Now, on the second column, there is also an option to exclude participants. So in this case, let's say I would like to exclude any participant who is pregnant. So you can just search pregnancy here. And in this case, again, there are different essentially data sources here. So for this exercise, we're going to actually select the survey information on whether or not a participant was pregnant. And so here we can see there is a survey question, are you currently pregnant? And we can press a little arrow, kind of open up this drop-down menu here of the possible responses to this survey question. So in this case, I'm going to click yes and click finish and review, and then save this criterion. And so this will help me exclude participants who responded to the survey saying that they were pregnant. So overall, the total number of participants in our cohort is 20,935. And once you're done specifying all of your inclusion/exclusion criteria, you can click create cohort. So I'm going to name this cohort type 2 diabetes test and go ahead and save. And once you've saved this, you can have an option to create another cohort, create a review set, and also to create a data set that you can use for your downstream analysis. So we're going to go ahead and click on create a data set. And the first step is to select the cohort of interest. So for this analysis, I want to look at the type 2 diabetes test cohort that I just created. And here we can select the different rows in our data. So let's say I want demographics information as well. And then in the third column, we can select or unselect certain columns in that demographics table. Okay. So once you're done, you can click Preview Table here to get essentially a view of the row level data, but I won't do that here. Once you're done, you can click Create Dataset, and let's say I'll call it Type 2 Diabetes Test and save. And once that's saved, you can click Analyze on the bottom right. And so what this is going to do is it's going to export the data set that we just created to a programming language or Jupyter notebook. So currently we offer 3 different types of programming language. You can select your favorite coding language, and you can export it to an existing or create a new Jupyter notebook. And so I'll just call it test, but let's show you what the code looks like. So essentially it would just translate all of the inclusion-exclusion criteria that we specified to SQL code. And so this is a very easy way to kind of jumpstart your analysis with building a cohort. Okay. So with this, we're actually going to launch into our third exercise. So I would like everyone to go ahead and try using the cohort builder on the researcher workbench and create a cohort that meets the inclusion-exclusion criteria below. So we'll be looking at the same 3 inclusion criteria, but now with modifiers. And once you're done building this cohort, go ahead and answer the question, how many participants are in this cohort? Okay. All right, so hopefully everyone had a chance to practice with using the point and click tools, using Cohort Builder. So now I want to take everyone through the second approach for building a cohort, which is instead of using the point and click tools to go directly to the Jupyter Notebook or any other analysis environment that we currently provide. And so this approach has a higher learning curve because it does require basic understanding of SQL. However, it does offer additional flexibility for cohort queries and data manipulation. And this is especially useful for dealing with longitudinal data sets like EHR data. All right, so in exercise 4, we're going to build a cohort using SQL. So before we do that, I would like everyone to navigate to their researcher workbench. I'm sorry, am I sharing my screen, Michael, or?
Yeah, we can see your screen. You're good to go.
Okay, awesome. And go ahead and click on the Analysis tab. So under the Analysis tab, you're going to see 2 different notebooks. One is titled Exercises, and the other one Exercises with Solutions. So go ahead and select Exercises. And you want to click Edit. And then this will just take a moment to resume the Jupyter environment and spin up the notebook for us. Okay, so go ahead and take a moment to do that. And I will go back to the slides. All right. All right, so now for exercise 4, we're going to practice building a cohort using SQL. And so specifically, we want to build a cohort of participants with type 2 diabetes, A1C measurement greater than or equal to 7, and metformin in their EHR. And so in the red here in the parentheses, I put the standard concept IDs here. So the question that we want to answer is how many participants are in this cohort? Okay. So now when it comes to using SQL, I like everyone to think about the mnemonic, the what, the where, and the who. And so this is essentially an easy way for me personally to remember some of the key SQL statements I will be using over and over again for cohort queries. So the first part is to use the select statement to specify what variables you want in your output table. So let's say we select person ID, then your output table is going to have person ID as its only column. Now, if you select person ID, race concept ID, ethnicity concept ID, then your output table will have those 3 columns. Okay, so the second part is to use the from statement to specify where the concepts live, right? So remember that in John's patient journey, we have 3 different concepts: metformin, type 2 diabetes, A1C, and earlier we found out that these concepts live in different OMOP tables, right? So metformin is drug exposure, type 2 diabetes is condition occurrence, etc. So we use the from statement to specify which OMOP tables contain those concepts. Last but not least, we want to use the where statement to specify who the participants of interest are. So we want to specify the inclusion and exclusion criteria that define our cohort, right? So in our case, for this exercise, we want type 2 diabetes, A1C greater than or equal to 7, and a metformin. Okay, so here's the code, and we're going to walk through this line by line. So remember the what, the where, and the who, right? So remember the first part is the what. So the question is, how many participants are in this cohort? And to answer this question, one way to do that is to count up the number of unique participants in our cohort, right? So the way we can do that is to essentially count how many distinct person IDs there are. So under the select statement, I want to select the distinct condition occurrence dot person ID. And here the syntax means OMOP table dot column name, right? So I want to select the person ID column from the condition occurrence table. Next is the where, right? So remember, we talked about the condition occurrence table, the measurement table, and the drug exposures, right? So here I'm essentially just taking these 3 tables. So I want from my data set, I want the condition occurrence table, the measurement table, and the drug exposure table. And I want to join them by person ID, right? So I want to join the condition occurrence and the measurement table where the person ID in both tables is the same. So if we think back to, again, OMOP and thinking about the data structure, all of us data is in a relational database where there are multiple linked tables. Within each table, we have a key variable, for example, person ID, that allows us to join tables. And so here in the code, we're essentially joining the 3 tables here and looking at the intersection of the 3 tables. So as a side note, SQL does have different join commands, for example, left join, inner join, outer join. But if we just use the shorthand join, that's actually using an inner join, where essentially we're looking at the cohort participants who have an entry in the condition occurrence, the drug exposure, and the measurement table. Okay, so that was the where. So now for the third part, we want to specify who the participants of interest are, right? So we want participants with type 2 diabetes. And so we want to specify condition occurrence dot condition concept ID equals to 201826. Again, this is, a standard concept ID that we can look up using Athena. So we also want people with A1C measurements, right? So we want measurement dot measurement concept ID equals 300441110. But we don't want just anyone with A1C. We want people with A1C values greater than or equal to 7. So we can additionally specify measurement dot value as number greater than or equal to 7. Okay, so you might be saying, wait a minute, where did you get this column name? Where is this value as number coming from, right? So, well, that really goes back to the OMOP tables. Remember the first resource that we looked at with the different OMOP tables and the different columns, right? So if we scroll down in the measurement table, we can see the different types of columns that we can specify. And so here, if we want a specific value range for our cohort, this is where we can use value as number to specify that. In the previous breakout room, one of the attendees asked about diagnosis date. So similarly, if you want to search for participants who are diagnosed on or before or past a specific condition start date, you can use specific columns in the OMOP table to help you subset that cohort. Okay, so all right, and so considering the time, we're just going to work through this exercise together. So if we flip back to your exercise notebook, hopefully everyone has their notebook spun up. And so it'll look something like this. If you were not able to spin up a notebook, please let the TAs know in the chat. So essentially in the beginning of the notebook, this will essentially mirror what I've talked about for the first half of the lecture. So this is essentially mirrors the slides a little bit. And if we scroll down to exercise 4 here, building a cohort using SQL, then you will see this code chunk here. And so what you can do is select this code chunk just by clicking on it. And then go ahead and go up to the top left and click run. So this will execute the code within this cell. And if the code is executing, you'll see an asterisk within the brackets here. And once it's executed, it will be replaced with a number that indicates the order in which the cells were executed. Okay, so go ahead and execute this low libraries code chunk first, and then also execute the exercise 4 query. So here in the red, that contains the SQL code that we just went over in the slides. So go ahead and select this cell and click run. I'll take a minute to execute, and then here is the answer to exercise 4. This cohort consists of 3,155 participants. So are there any questions about exercise 4, essentially using SQL code to perform queries?
I have another questions because
Yeah.
in the inclusion criteria, the patient age was more than 50 years, but in here, the Python code, the SQL code, you are missing this, patient
Yeah, that's
age.
a great question. So from the previous one, with the Cohort Builder, that was essentially a standalone exercise. And so if we're just looking at exercise 4, we're specifically looking at just these 3 inclusion criteria. But I agree, if we're looking at a cohort of people greater than 50 years of age, we definitely want to specify that in the code as well. Okay, so this is a separate exercise. Yeah.
Thank you.
Yeah, but I think you're definitely getting the hang of it, is to understanding how to specify some of those modifiers in the code. Okay, so considering the time, we're actually going to skip the breakout room for exercise 4, but just to give everyone an overview of what this exercise entails. So for this one, I want everyone to try using their Jupyter notebook to build a cohort of participants with, instead of type 2 diabetes, type 1 diabetes, and then A1C measurement less than 7, and also insulin in their EHR. So on your own time, if you scroll down to exercise 4, now you try. In the code here, I have these question marks that you can replace with the correct input. So we won't go over that today, but in the other notebook, the exercises with solutions, you will actually find the solutions to all the material and exercises that we went over today. Okay, so we're gonna just go ahead and go to our last exercise and thinking about how to deal with really harnessing the temporality and longitudinality of EHR data. Okay, so let's go back and visit our friend John Doe. So this is his patient journey. So in January of 2019, he had an AFib. And so at that same visit, he had an electrocardiogram, or an ECG. And so on the left here, you can really see how the patient journey has expanded to incorporate different aspects of EHR domains, right? So an ECG would belong to the OMOP table, procedure occurrence. Okay, so here's a little bit of background information. There's prior research suggesting that higher A1C values, so blood glucose values, are associated with higher risk of AFib. To diagnose AFib, doctors often order an ECG to measure the electrical activity of the heart. So our objective is to explore whether there is a longitudinal trend in the A1C values leading up to the time of ECG among individuals with type 2 diabetes. Okay, so this exercise is a little bit more involved. So now we're moving beyond building a cohort, but really thinking about how we can draw conclusions from EHR data. So for exercise 5, we're going to start with the cohort in exercise 4. So the type 2 diabetes cohort, we're going to try to subset it to just those who have had an AFib and an ECG. And then among those who have an A1C value between a pre-specified range of 6.5 and 10, so that's the diabetic range, we want to calculate the average yearly A1C value for up to 5 years before their ECG. And the question is there a time trend in the average A1C values leading up to the ECG? Okay, so we're going to break this down bit by bit. So thinking back to the mnemonic, the what, the where, and the who, we can start with the first question is what variables do I need to answer this question, right? So the goal here is we want this XY plot where we have the average A1C value on the y-axis, and then the number of years until the ECG on the x-axis. So we need to calculate essentially the average A1C values over time, right? So recall that in John's patient journey, he had 3 different measurements of A1C leading up to his ECG. So let me just strip away some of the noise and make this more clear for everyone. So John had 3 A1C measurements leading up to his ECG. He had 2 in 2018 and then 1 in 2019. So overall, he had 2 average yearly A1C measurements, 1 in 2018 and then 1 in 2019. Okay. So one thing I want to point out when it comes to dealing with EHR data is that different participants have very different timelines. So we've got John in the upper right here, but Billy and Nancy have very different timelines. So for Billy, he had his ECG in the spring of 2017. And prior to that, he had 4 A1C measurements in 2016. Nancy had her ECG in 2018 and also had a number of A1C measurements before then. So can anyone tell me how many average yearly A1C values does Billy have, given this timeline here? So we know that John has 2, right? 1 in 2018, 1 in 2019. How many average A1C values does Billy have?
4.
Yeah, well, these are, since we're interested in the yearly, so the answer is actually 1 because he had his measurements all within the same year. And we're looking at the A1C values average across years. Does that make sense? So for Billy, he only has 1 mean A1C value in 2016. Okay. And then in contrast, Nancy had 2. She had 2 measurements in 2016. So that'll give her a yearly average in 2016. And then 2 measurements in 2018, that'll give her a yearly average in 2018. So really, this is to illustrate really the complexity of EHR data. And one of the advantages of using SQL is to be able to manipulate and wrangle this data before you use it for analysis. Okay, so let's again take this bit by bit. So again, let's think about what we are interested in looking at, right? We want to look at the average A1C value trend over the years before the participant had their ECG. So in this case, the what statement, we want to specify the person ID just to keep track of everything. And we also want the yearly A1C average. So in SQL, there are actually shortcuts to just take the average value of a specific measurement. So here I'm taking the mean of the measurement value, and then I'm renaming it as annual average. So that will be my y-axis, right? For my x-axis, I want the number of years before their ECG. So in SQL, you can use this command called extract, which will essentially just pick off certain components of, let's say, a procedural date. So here I'm just picking off the year from this participant's procedural date. And then I am subtracting from it the measurement date, right? Because I want to just look at the measurements leading up to their procedure, their ECG. And so then I'm storing this difference as year until their procedure. Okay. So that was the what. Now it's the where. So this again is thinking about which tables are we looking at and then doing the merging on the person ID. So here we're looking at the measurement table, the procedure occurrence table, and the condition occurrence table. So here is where we specify. Yeah, go ahead, Yvonne.
This might not be important, but when you did select and you rewrote it as annual average,
Yeah.
lowercase, but then the next one, when we rewrote it as year till procedure, that is uppercase. Does that not matter?
Yeah, so that's a great question. So typically with SQL commands or statements, they're usually capitalized. So if something is capitalized like from, average, extract, year, from, things like that, that's kind of indicating, at least to me as a coder, that, hey, these are SQL statements and SQL commands. With annual average, that's just what I'm naming the output column of my data. So you can name it whatever you want. It can be capitalized or not, but in general, when it comes to writing SQL code, you want to capitalize the commands.
Yeah, it was the AS that was capitalized one place and not.
Oh, okay.
But thank you.
Yeah. Thank you for that question. Okay, so let's keep going. So for the who part, we want to specify that we want participants from exercise 4. So again, this is another trick where in SQL, if you've stored the person IDs from the previous exercise, now you can say, hey, instead of rerunning that cohort query, I just want the person IDs that correspond to the persons that I've already restored from the 4. Okay. So in addition to that, we want people who have an AFib. So condition occurrence, condition concept ID equals 31217, who's had an ECG and an A1C value between 6.5 and 10. And last but not least, I just want to restrict to looking at the A1C values up to 5 years before the ECG procedural date. So I want to specify the measurement date to be before or up until the procedure date. I want to group the information by the number of years before the procedure and also the person ID, just to keep track of the different people and the different yearly A1Cs that they have in our data set. And last but not least, I want to look at just 5 years before the ECG. So I want year till procedure less than or equal to 5. Okay, so I'll take questions in just a little bit, but once we run this chunk of code, you'll see this is the final output. And so the takeaway is that if we look at the x-axis going from number of years until ECG, moving from 5 years before to 4 to 3 to 2 to 1, we see that there is an increasing trend in A1C values leading up to the ECG. So this suggests that higher glucose levels may be indicative of heart problems. Okay. So for this last exercise, I would like everyone to go into their Jupyter notebook and try subsetting it to those who've had an AFib and an ECG. And among those who had an A1C value between 5.7 and 6.4, which is the pre-diabetic range, we want to calculate the average A1C values up to 3 years after the ECG. And we also want to answer, is there a time trend in the average A1C values after the ECG? Okay. So I think we'll just set up a very quick breakout room so everyone can try it out. So in the Jupyter notebook, you want to go ahead and scroll down to the very bottom, exercise 5, now you try, and then go ahead and try replacing some of these question marks in the code with the correct answer. Okay, so I think we'll just do a quick breakout room for 5 minutes and we'll come back and discuss this as a group. I think we have everyone back. I'll just quickly go over this, the solutions to this exercise. So for exercise 5, I'll just go ahead and share this one instead. And Michael, can you see me kind of scrolling on my page?
You're all set. Thanks.
All right, so for this question, we are looking at the time trend of the average A1C values after the ECG, right? So during the lecture, we were looking at the trend before or leading up to the ECG. So for the first set of question marks here that you want to replace, essentially you want to subtract the procedure date from the measurement date instead of the other way around for the previous exercise. Okay, so that's for the first set of question marks. For the second set of question marks, we're interested in people who have A1C values between 5.7 and 6.4. So then we can specify that here, where we specifically want measurement values between this range. So this is looking at the pre-diabetic range. So for the second to last question mark, we want to look at again, the A1C values for 3 years after the ECG, right? So we want the measurement date of the A1C values to be after the procedure or the ECG date. So this here should be a greater than or equal to sign. Okay. And last but not least, we want for up to 3 years after the ECG. And so here we want years after procedure to be less than or equal to 3. Okay, so that should cover all of the question marks. And again, if you want to look at the complete solutions to today's exercises, you can look at the solutions, exercises with solutions notebook. So if you execute this code chunk, you're going to see something like this. And we'll just go back to the slides. So overall, there is a decreasing trend in the A1C values after the ECG, and this may suggest many different things. Perhaps one guess is an improved glucose control for diabetes management. So that concludes today's workshop. Are there any questions about exercise 5 or anything else that I can answer today? Awesome. Then I think, Michael, we're ready to wrap up today's session. I'll stop sharing my screen.
Perfect. Thank you so much, Cathy, for that fantastic workshop. It was great to have that. Thank you, everyone, for attending and being part of this. And I just want to pull up one thing very quickly. Let me just share my screen. Technical issues. Here we go. Yeah, we can pull this up. We do have a survey that is available. If you can go in there quickly, it's a very short survey. I just put the link into the chat. We would love to get your feedback on how you enjoyed the workshop. If there's ideas that you have for future workshops, ideas that you have that feedback that we can get on how we can make this even better in the future. We'd love to be able to put on more workshops like this. And all of your feedback is crucial for making this a better product going forward. So thank you all so much for attending. With that, we have a couple additional resources for your ongoing journeys through being an All of Us researcher. We have office hours, so we have a live event calendar that is on our user support hub. We have for registered users, we have every Tuesday office hours where you can come in, ask for any sort of question. You can pre-submit questions, make sure that we get to that. We also have Friday office hours every other Friday, and these have normally a theme to them, so a specific kind of subject material or data set that we're going to be working with, and monthly new user orientations as well. We also have an awesome support staff. If you had Sam Stewart as your TA, she leads our support team. Feel free to always reach out to us at support@allofus.org. Sam can put the link in there, and we will be happy to answer any kind of questions, any issues that you encounter. We have a feature workspace intro to all of us electronic health record data to also jump into. So tons of resources to check out. If you're ever stuck at any point, always feel free to check out what we do have available. And if you don't find it, then you can always just reach out to us. And with that, now that you're done, feel free to delete your environment, delete your persistent disk. This will kind of help save your costs, so you're not kind of continuously running that environment if you're not using it. If you want to keep jumping in there and keep working on it and exploring, by all means, feel free to. But just for your own kind of knowledge and use for housekeeping tips, we recommend deleting your environment and persistent disk. If you haven't had anything saved that you want to keep around for a long time there, feel free to delete that and you won't kind of have those monthly ongoing charges. So with that, that concludes this workshop, and thank you all so much for joining. It was great to have you, and thank you.